Hey everyone, welcome to Whitmore's Trains. My name's Wes. Today's topic is train automation, and I wanted to explain how I used MTH's ITAD device to automate the running of 3 trains on my own layout. I built a relay board, which later on in this video I'll go even more in depth if you care to know about it. But I'm using 5 MTH ITAD devices on that board. Now my solution only uses 4 individual relays, so I do have an extra. Let's go over what it takes to make these trains run, and then we'll fire them up and I'll do a walk around and show you how they work. So each of the 4 tracks that I'm using to start and stop need 2 things. They need a start-stop track, and they need actually 2 ground trip tracks. And I'll show you what those are for. Let me show you the 4 now. So it's this one and this one. Now these are both the isolated center pin, because there's an insulator here and an insulator here, and then on the one behind it there's one here and here. So these center rails, you can see there's a wire on each, they go back to the relays. They do go back to the relays, 1 and 2 of the 4 that I'm using, and they supply either the stall voltage of 6 volts or the start voltage of 18 volts to make the train start and stop. The other 2 I'll show you now before I forget are this one goes to here, and this one is further back, and it goes from here to here. Now almost all 4 of those are basically built the same, where they have the isolated center rail stop-start track, but in front of them they have a ground trip track. And the reason there's a ground trip track in front of it and not behind it, because behind it is just regular 18 volt, command voltage, what I consider the rest of the track. So these ground trips here, which are isolated rails, you can see there's an insulator there, and then there's also isolation tabs for here and here. So what these are for is when the train needs to go back through a start-stop track without stopping, because I generally only want to stop the train one way and I want to continue to pass through the other. So this ground trip will allow that. So if a train was coming down the hill and into the table, the engine would hit this track, would ground through the rails, trip that relay, and then this start-stop track would then get 18 volts, and the train would continue on through until it got through that section, hit the same 18 volts as the rest of the track, and just keep going, almost like there was no start-stop track there at all. But as that train goes down and comes back the other direction, we do want it to stop. And we want it to stop because in my track, I share a lot of single tracks, I guess. So my 054 that goes up the hill is a single track, and my other 2 layers of 054 that go around are single tracks as well. So we need to share that. We want to stop the train until whatever train is occupying that is finished with it, and then we can continue on our way. So as this train comes up, we need to find a way to stop it, but more importantly safely start it. So an example of track 1 would be it would be stopped. It just come up out of the table, waiting for this train to come through this shared switch. And this switch would be in a diverted route already, because when the train went up the hill, it came through off this table through this switch and turned it red. So as this train comes back down, it will still be red, and it will come through, and then this switch, this is a passing siding, almost like a parking siding of 031. So we're only using that to park. We're not doing any train automation with it. So that makes it simple, because we always have this switch going in and out this 042. So as I'll call it the table train, because it only goes from the table level to the upper level and back down. So as the table train comes back down, it'll pass through this red diverted switch that was already red, It'll be through this fixed 042 that never changes. And then it'll hit the ground trip that it has to turn this start-stop track to 18 volts, and it'll pass right through like it never existed. And then it'll go around. And then when it pops out over here, let me zoom in, that switch over there will either be in the straight or the diverted, depending on where it was last, because it is it's not powered, it's also passive. So let's say it was set to divert, it will come across a ground trip section that is in between those two tracks. And that ground trip is wired back to the relay of this train, which is relay 1. So there are 2 ground trips per track. This one that lets it go through always, and then that one which releases it when the train is stopped and it's safe for it to be released. So the red train will come down, hit that track, which means that this train is safely off of the layout and it's okay for the Amtrak to continue. Then the Amtrak will be released. And then that table train will finish its loop and stop at its stop track, waiting for another safe trigger from another train. So let's walk around and I'll show you that trigger. So this corner is the second ground trigger for the table train. And this, the reason this trigger, which is right here, is at this location is because it's far enough away from that switch that it's safe for the table train to go back up and back down onto the table again. So as the Amtrak example, as this Amtrak goes up, then comes back down straight, working its way down into the table, it will hit this ground trigger and send the table train, which is the 1976 train, but which would be parked here, back up and then back down onto the table again. And as the table train goes onto the table, it'll do its 042 loop again and then come to a resting stop where it just was released. So now, with the Amtrak continuing on down into the table, it will reach this point, which are our passing sidings. There's an 042 and an 054 loop in there. And you can see that there's already a Santa Fe on the inner 042 loop. Now this passing siding goes from here all the way around a big U shape, back down into a single track on the other side, where it continues its 054 down to the bottom. So as the train goes back down the way it came up, because if the train was on the outside going up the incline, it's in a straight position. So whatever comes back down will be in that same position. It will continue on the outside track, passing the parked Santa Fe until it reaches this ground trigger. Now there are 2 ground triggers. One is on the outside and one is on the inside. The outside will release any train that is parked on the inside parking siding over there, and vice versa. An inside train will release any train parked on the outside over there. This is a non-powered switch, so if a switch is in a straight position from the train, it'll continue to switch in straight until it comes down here. And then it hits this powered switch, which will either go left or right, depending on where it was before. If a train came up from the straight last time, a train was down here, then a train will go down the straight, work its way around and come back up. We can either push a train to the inner 042 or the outer 054. The outer 054 is set for yard work, and so that CSX will be bypassed when a train comes down here, because it was working on some yard work stuff. So anyhow, as the train goes around, comes back up, it has already released that Santa Fe that was parked on the other side. And it will continue on the outside. It will stop on this track. And this train will not be here because it was already released. So we just continue to use that same start-stop track and ground track functionality to get the 3 trains to go around on this layout automatically. Next, I'm going to show you a video of these trains moving, and I'll call out the the ground trigger functions, and you guys can watch the trains be released and make a little bit more sense of it. Okay, I'm just going to attempt to walk you guys through some of this. So this 76 train just came down, and the Amtrak will stop because it reached this track section. So that train can, so the 76 train can pass. So depending on which way the switch is set, and I'm not sure, so yeah, it just hit that ground section, which releases this train. So the Amtrak will go up, do its its route, and it'll come around, and will continue to go down into the table. Because as it comes down, which is this train, as it turns on and comes down, its own wheels will hit this ground section, which will set set the ITAD number 1, we'll call it, to the 18-volt position, and energize this rail, which is normally 6-volt resting, to 18-volt through this section. And then once it gets to here, it's you're past the relay section, and it's just regular 18-volt command, and we'll continue on down. So this train here has just finished its table run and will stop because it needs to stop to let this train come back down. So let me see if I can speed up a little bit here. Okay, so we're going to speed up the Amtrak some. And turn off smoke. Okay, so it just hit the ground section, relay clicked, and it continues on down. So this train, the Spirit of 76 train, is going to sit there until the Amtrak hits that ground section right there. As you can see, it released that train. So that Spirit of 76 train just went through this switch and just diverted this switch. So now when it comes back down, it will go to the table as opposed to going down into the layout. And that's important because we're going to have a train coming back up the helix onto this section. So while I was talking, let me back up here. This train was just released by the Amtrak train, and I'll show you how that worked again. So the Amtrak went to the outside, which was open, because the Santa Fe was on the inside. So as the Amtrak came on the outside and hit this ground trigger, it released the Santa Fe to come back up. So, and then the Amtrak went down, just did a loop, came back up, and since it was the last one through that switch, it went straight. So it's still straight. So this train will go around and stop on the outside of the beginning of this passing site. And it'll sit there and wait because now the Santa Fe is blocking the way up to the top of the table. So the Santa Fe went up the helix when it was released, came all the way around and parked here, and it cannot go any further because the 1976 train was in the way. So now we're just about into the safe zone where we're going to hit that ground trigger over here, and when we do that, this train will release. I just hit my bridge there, so I'll have to fix that. But this train will go up and turn around and come back down, and this train will stop because there's no space for it. Alright, so this train will sit here until the Santa Fe gets around to right there. As you can see, it takes off. And the process just continues. So that's how I do it. There's other ways to do it, but that's the way I've been doing it for a long time. It's always worked for MTH trains. So, and I can bypass it. I can turn it off if I just want to go back to running, command with remotes. And I usually have to use 2 remotes because I'm moving. I have to start and stop a lot of trains, so it's just easier with 2 remotes. But I can do it with 1, or I give Max the other one and we run it together. So it's just nice to be able to turn them on and let them go. If you have any questions, just throw something in the comments and I'll be happy to talk about it. And have a great day. Good morning, everyone, and welcome to Whitmore's Trains. The video that you just finished watching was a demo of what this relay board can do. And if you have a dog bone layout but want to run multiple trains at the same time, obviously you can't turn all the trains on and just let them go. So you have to have some sort of train automation. And I developed this system back in 2006 when I got back into O-gauge trains after college. So what I ended up needing was I wanted to be able to stop a train but not have it shut off. So I wanted was something where I could pause the train but keep the smoke going, keep the sound going. I use an MTH remote. I set my transformer voltage to 18 volts. I'll crank up my scale speed to say 20, and then that train will come around the track, and when it hits a certain special, I'll call it a stop track section, the train will stop, but it'll stay, making noises and smoking and stuff. So how I do that is 2 voltages. An MTH steam and diesel locomotives, they'll stall at around 6 or 7 volts. And what that means is, if you had it cranked at 18 volts, like you would on command, you're going 20-mile-an-hour scale. If you take the transformer and bring it down to 6 or 7 volts, that train will stop moving, but all the sound will continue to go. The smoke will continue, and the engine will not shut off. And you go much below that, and it will shut off. So what I ended up doing is I just use what's called it's a rectifier circuit is what it really is. And I'll get into that soon, and I'll show you how we can strip the voltage down from 18 volts down to 6 volts, so it'll stall that engine when you need it. So I'll come back to this in a second. So the actual relays are just MTH ITADs. And they had these clear back in 2006. And I was an MTH guy, so this is what I bought from my local hardware shop. So MTH ITAD, before you break it apart and rip everything out of it, plugs into Realtrack's track, so for your track power, or you can power it with auxiliary power. And then so this is the relay delay. So when the relay is triggered, you can set the relay for how long you want it to stay closed until it releases. So I'll get into that in a minute. So common, normally open, and normally closed. So when this relay is powered, you can send out the same voltage that you power the relay with. So we'll call that 18 volts. It'll send 18 volts either out of the normally open or normally closed, depending on the status of the relay. And then there's a switch here to switch between powering the relay with track power or auxiliary power. And then, so this is the sensitivity for the infrared. So you guys know what infrared is. It comes out of a sending and receive unit out of that. So let me set this down here. So when a train comes by normally, you'll set the sensitivity screws so so it'll activate when the train's there, or there. So just you have to set that once. So these are used for like crossing gates, anything momentarily activated by motion. But I don't think the infrared's very reliable, I guess. So back in the day, what I ended up doing was just taking this thing apart, because I didn't feel as an infrared unit was doing very well anyhow, and to see how it worked. And there's the red and black wire goes to a send unit, and what was the yellow and black wire is the receiving unit of the infrared system. So to get the actual ITAD out of it, I just end up cutting these wires off and cutting the 2 wires off of the switch, and then you just throw this thing away. So we'll bring us down here to the board now. So this is what was inside that ITAD, but what I discovered was if you put ground on, this is the receiving eye, if you gave it ground, it would actually trip that relay, just like it would be on motion. But it's so much more reliable. So I've been using those for the past couple of years. Actually, way more than the past couple of years, but they work super reliable. If you look, these two have like Cat 5 wire, and that's from 2006. So I did not rewire these when I put all 5 of these in. So you'll notice that these are using twisted pair, and then these 3 are using 18 gauge HVAC control wire. So 18 gauge solid wire is good for 14 amp. And that's pretty much what I use on all of my track, on the whole layout, because I'm on 14 amps a lot. And it's also, this stuff is, you can really bend it, you know, so takes 90-degree corners great, and you can solder it just fine. And it's actually pretty cheap. And if you can buy it in 2 different rolls, you can buy it in a 2-conductor, like a white and a red, just for like a thermostat wire, and that's cheaper. Or you can buy the 5 wire, which is a yellow, a green, a red, a blue, and a white. You know, so you just cut the outer sleeve off, and you know, you've got 5 different wires to use. So there's no black, so I use green for ground. But you know, that's just give you an idea of what this wire is here. So back to the ITAD. When you supply a ground to, you know, these yellow wires, it will trip that relay. So what you end up needing are 4 different wires to make these relays work. So the yellow, let's scoot it over so you can see them. So the yellow wire is a ground trigger. The green here, those are just ground. Go back to the common on the transformer. The red wires are pretty much 18 volt AC, because I crank up my Z4000 to 18 volt, because that's probably the maximum recommended voltage to use these. So I set it at 18, so when I do my voltage reduction, it's repeatable. And this has been working for years. So and then blue. So blue is the output of the relay that I really use. It's this one here. So this is a common, you know, we don't use that. We don't have to send that to the track. So we either send a normally open or normally closed and normally open. So normally open, when this relay is energized, because, you know, the transformer is on, power will not come out of that output. But when you trip the relay, 18 volt will come out of that output, which is the same power that's going into the relay. So, and where that goes is to these sections here. So, you know, I've got 5 ITADs, and I've got 5 outputs. And I'm only going to use 3 for my layout, but I wanted to put them on the board for future expansion. So those yellow wires, they're the ground triggers. So they correspond, you know, these 2 are tied together, these two. So when you supply a ground trip to this, it'll turn the relay on, and you'll get 18 volts here. And, you know, and all these are independent. So, you know, if I trip this one, they don't all send 18 volts. It's just, you know, 1 for 1. So keep that in mind, because I'll show you where that matters later on, because obviously you don't want that to happen. All your trains would go off at the same time. But there's a fix that I had to do to make that work. So let me talk about, because I don't know if everyone knows, I mean, you guys do know that I use like Lionel or Menard's 10 plate. And it's pretty simple stuff. So in all track, the outside rails are tied together, because there's no insulators, you know, where they join the cross member on these 2 tracks, but there are on this track, and you can see they're all that same way. So the middle one is the positive wire, or sorry, is the positive rail, and it needs to be isolated from the outside rails. But if you want to use a ground trigger, which means you basically want to isolate one of these rails, so when a train comes that has, you know, metal wheels with a metal axle, it'll hit the ground. The charge will go through the axle, which is touching the other rail, and then you send ground. Because of that, you're sending ground through that wheel, and then this will become, have ground again. So then we end up putting a wire off of that and then do something with that wire. But to isolate it, we need to make it like the center rail and put the cardboard in it. So magic of TV, this is what I'm about to use. So these are easy to make with tin plate. All you do is take a screwdriver and pry out these tabs, and they're super easy to pull out, and there's 2 on each. And then you have to do the same thing with the sacrifice rail, because you need to get the positive off of, so you can get that paper out. So you end up, peeling off the center rail off of a donor piece of track, get the cardboard, wrap it around the rail, put it back down in, push those 6 tabs in, and you're done. So once that's done, had one here, I must have fallen out when I was winging it around, but there's an isolation tab, not here. So they're little nylon pins basically, and you'll put one here, and you'll put one here. So at that point, that entire track is isolated until metal wheels touch them and will then send ground to that. So keep that in mind. So I may send this, like if this were an imaginary track, let's say that's where my locomotive is sitting there waiting in idle in low voltage, and I'll show you how we get that low voltage. Another train clear over here on this side of the track will go across that ground, and when it does that, so the wire is coming over here and plugs into this first trigger, then the trigger comes up. I'll just pick one of these. It's yellow. So yellow will come in and go right back out to that wire. And these are built like this just so I can work on them. So I can find out if I have a fault going that way. I can find out a fault if I have going this way. So that's why I use these strips. So, ground comes in here, trips that, makes the relay send 12 volt out of the normally open wire, which will come in here and then hit here, and then pass on to my output of here. So this wire will then go out to the isolated center rail. So, this one's already isolated because of the paper. I just have to put in 2 fiber pins here, and then this rail becomes isolated from, the center rail to the left and to the right of it. So at that point, 18 volts is applied to that track, and the train goes. And it'll stay charged as long as there is a car parked here. So let's say you've got a 3-car train that goes past, at this point, the engine hits it, ground, does that, releases the train, but, you got 3 cars passing. It may take 2 or 3 seconds for that to happen. It'll hold that relay closed for X amount of seconds after the last car left that track. So, so this may be charged for 5 seconds or 6 seconds, which is plenty of time to send the engine out of that start section of track. And then once it's 5 seconds has happened, it'll go back down to the stall voltage. For the next time that train comes in, it'll stop, and the whole process will start over again. So what's a little bit different here is we have to find a way to reduce and make a stall voltage. So what these are, they're called bridge rectifiers. And I believe, I'm no electrician, but I believe there are 4 diodes in here wired in a certain way. So what I do is I just buy these off of Amazon. And this first strip, I don't know if you guys even know what Radio Shack is. I bought those in 2006 from Radio Shack. The ones right below it, a little bit shinier and cleaner, bought them off of Amazon. And you get 5 of them, and here's the number, for like $9. So that's super cheap. So I use 12 of them, and what these are is they reduce voltage because of how you wire them up. So if I can get in here, you see that there is a cutoff corner right there. So I might even put one of these together for you guys. But I'll put cutoff corner to cutoff corner, and then I'll do another cutoff corner to cutoff corner. So what this does is, let's walk through one of these, so might be able to see better here. So I'll bend these together, and then I'll bend these the other way, and then I'll bend this is the third set together, and the other way. And then I connect the ones that are left together. So you can see it's like a little zigzag pattern all the way down. And then I'll just solder them together so they stay that way. So what ends up happening with a bridge rectifier is it'll reduce voltage about 1/4 of a volt at each leg hop. So, I've got 12 of them. So you start at 18 volts coming in, and I'll show you where that power comes from here in a minute. So much to show you here. But so, 18 volts, 17 3/4, 17 1/2, so, 17 1/4, 16, and on down. So we do this because there's a magic sweet spot that you need to find that will stall the engines. And once you find that, it's the same, it never changes. But if you end up not setting it at 18 volts, then the stall voltage on the output will change, so you may have to move these. So that's why these are on alligator clips, so I can move them around until the engine stalls. And once it stalls, that's it for that strip, and it'll stall all the MTH engines, which is really the magic of how this all works. So I think I explained how the bridge rectifiers work, explained where to get them. I need to solder them together, and I showed you that too. So let's walk through the circuit here real quick. So I broke these out as well. There's 5 of them because I do have the ability to run 5 bridge rectifier strips if I want to. And then downstairs on my layout, when I put this back on, I've got a ground and a positive bunch block. So I'll just run, 5 wires of ground and 5 wires of positive to those to those bunch blocks. So then that will power all of these up. So I know there's a bunch of wire here, so let's just go through one. And it's really not bad because remember there's only 4 wires that we're caring about here. So but I need to show you this to show you how we are adding or layering on the 6 volt and the 18 volts. So we'll go through one. So 18 volt comes in, and 1 wire just goes to here. And I already talked about it, how as these go down, you drop voltage. So let's just say that's 6 volts here. And I'll do the ground too. So the ground also are all bunched together and just go back to a test transformer. And then, so anything green you see is ground. So back to the positive. So that's for the low voltage output. And the low voltage output, because of these alligator clips, right here is 6 volt. So keep that in mind. So the power to run the relay are the other long red wires. So they'll come here, and we'll just pick one. So this right here is, 1 wire coming in, and 1 wire going to the relay for its power. And then you've already seen the grounds. They come up here and go in here, and then go right back out. And then they go to the black wire of the relay. So there's your 18 volt and your ground. And then there's only 2 more. So there's and you've seen these already. This is the ground trigger. So that's the yellow wire that comes from here. There's 5 of them. And then there's a matching, normally output. So you see the blue wire, it's one of these. Blue wire comes in, goes around, pops up, and this goes to that track section that we talked about right here. But we also use that same lead because you see the red wire in there. Well, the red wires come over here to this low voltage section. And then they're just summed here and go out the same wire. So what that means is when the relay is not on, meaning there's nothing on that ground track to trip it, then whatever voltage you've set here is what's going to be on the resting track, because it'll come in through, pop around, comes in here and goes to the blue wire and goes out to that track. But when you have a ground trip, then it trips the relay and applies its own power of the relay, that 18 volts, right on top of the 6 volts out the same wire. And then that track will have 18 volts, and then it'll continue on where it was before it stalled. So that's how all of these work. There's 5 of them, and they're all wired the exact same way. So I think I've explained what most of this is, and it's not so bad when you get to look at it. I would like to, I think I'm going to build another strip, but I figured having one more extra wouldn't hurt. So I'm going to wire that up and show you guys how to do that. And then we'll probably go run some more trains. All right, have a good day, guys. If you got any questions on this, let me know. If I didn't explain anything clearly, let me know. Have a good day. So I spoke earlier why we needed individual bridge rectifier strips. And it's because, and why not just like, share one, right? I mean, if they're all the same starter voltage, why not just tap off of one of them? And the problem is because we have these tied together, when you send 18 volts to, just from one relay, it actually, all the, since they're all tied together, they all get 18 volts. And you'll get 18 volts out of all 5 of those, not just one. So with the bridge rectifier strip, it only allows power going in one way, and it's a non-issue. So as long as you use one bridge rectifier strip per relay, you're set. And whether like $8, $10 a strip. So and it also continues to give you individual. If you ever decided you did need these output voltages to be different, well, since you're not sharing one, you'd be able to do that. So that's why we have 3 of them, and I'm about to put a 4th one together for you guys. All right, let's start building this here. So there's a hole in between them, and I don't know how well this is going to show up because I got a GoPro strapped to my head. But like I said before, there's a flat side. So all you got to do is just lead that with the flat side. And then you just get another one, and you put the cut sides, flat sides together in like 2-piece pairs, I guess. So, all right, and then so we'll just start zipping through these and getting them all in. Okay, it's tight. And then the next one. As hard as I try to make them straight, it's kind of hard to. So I'm just using number 6 by number 1 drywall screws. So all right, so that should be 12 of them, and I don't know if you can see with the GoPro, it's not as good as the iPhone, but notched, 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 and notched. Okay, I'm gonna pause this and start over once I know I recorded this. All right, I'm sure you guys can't see this as well as I want you to, but this wire, we'll just make it look like all the rest of them. This wire will be that. These, we'll do the crisscrosses first. So just kind of bend them. They bend real easy. And this one bends the other way. As you can see. And I'll go and get these 2 done. Started so you can see them. And then this crisscrosses this way. I'll just get them like started, and then I'll come back and make sure that I like them once they're all done. It's not that tedious, it's not bad. Get lost, just look at the line above it. It's been pretty easy. All right, that's pretty much the first pass. Second pass, I'll just kind of clean them up. Make sure, like, when I apply the solder that I think they're touching pretty well. Sorry guys, not the most interesting. I'll speed this up since I'm saying absolutely nothing. Sometimes you just can't quite get it. There you go. Gotta keep working at it. No one said this hobby was fast, right? All right. That's pretty good. Check over my game real quick. Feels pretty good. Okay. So then what I'll do, I don't know if you're gonna be able to see this or not. I'll just go down with a soldering iron. Might be able to see this one. Just put some solder on it. I mean, it's fine. These things never failed on me, and I'm not the best solderer in the world. I just heat up the two leads and put the solder on the wire. Try not to get too much of it on the tip. I want the actual wire to melt, not just dropping it on there. And this is just a cheap, I don't know, is it Weller? Is that the high-end brand? Well, this is just some like $18 soldering station from Parts Express. I'm sure you can get it from Amazon too. And I think you guys got the idea. I'm just gonna go ahead and finish this so I can start using this board again. All right, so there's that. And my next step will be to take a red wire, solder it on there, and then just attach it to here. So before we go run trains, I did want to demo this on the board because it's sometimes easier to see. So what we're going to do here is we're going to simulate a train taking off. So all I've done was I put this jumper onto the ground, which is the same thing as a train going past a ground trigger section. So what we're going to do here is, look right now, we have 13 volts. So that 13 volts, I believe, let's see if I can find out which one it is here. Yeah, so you can see it drop. So if I touch here, there you go. I don't have enough hands. So that's 16 volts. If I come clear down to here, it's 11 volts. But I know you're like saying, hey, you said 6 or 7 volts. So it all changes when there's an engine on. Right now, there's no load on this circuit at all. So as soon as you pop a train on it, what is actually is right around here. What is 13 volts will actually be 6 or 7 volts once you put the train on it. So so that's how this works. So at this point, we've got, I'm just running the voltage of that trigger track, that start track. So right now we're at 13 volt. So if I were imitating that was a train, you hear the click. Now we are at, see if I can hold it all together. There you go, 18 volts. So now I had to hold it with my hand. Take the ground off, the relay just clicked. Now you're back down to your starter voltage. So that's how this works. You can hear it clicking. So, and if I wanted to, try to do this with a phone, but I can adjust the delay here. So that was like 2 seconds instead of instant. And I think I can get up to like 9. See what we got here. Just clicked. So that's what, 5 or 6 seconds. So it's plenty of time because you're gonna have multiple cars past that and continue to hold that relay closed. And then at this, the first time the locomotive hit that track, you've already started sending that engine out. So you only need to get the engine out of the stop block. The cars don't matter because they're just getting drugged through it. So, all right, if you guys have any questions, let me know, and let's go run some trains. Thank you.